When reverse engineering products, it's critical that the parts produced are able to hold up to their intended application. Having parts that are properly toleranced and made out of the correct material is necessary to achieve ideal functionality. However, there are still additional factors involved in ensuring that a part performs as intended. Secondary treatment processes, such as heat treating and curing, can alter a component's physical properties, such as hardness or strength, which can make critical differences in a part's performance. This is why American Holt devotes resources towards verifying the mechanical properties of all parts we produce. One of the most significant properties we check for is hardness. A part that is not properly hardened can deform and easily wear down. Our main tool for hardness testing metal parts is a standard Rockwell hardness tester, able to accurately measure the hardness of materials from hardened tool steels to soft brasses. This tester functions by applying force to the surface of a part through an indenter. The shape of the indenter and the amount of penetration is used to determine the hardness of the part. For parts too large to fit in the standard hardness tester, we have portable hardness testers, which allows us to quickly and accurately measure hardness. These include our clamping dial hardness tester, and for very difficult to reach areas, a digital drop hardness tester. Plastic and rubber components are typically much softer than metals, and are often measured on the durometer scale rather than Rockwell. For this, we have a micro hardness tester, which measures penetration depth of an indenter on a smaller scale, and with higher repeatability. For parts too large to fit on this tester, we also have handheld devices. Springs are a common component produced at American Holt, and one of the critical aspects of a spring is its stiffness, or spring constant. For determining this vital characteristic, we utilize specialized spring testers. The amount of force required to deform the spring is shown to the user. Dividing the force value by the distance provides the spring constant value. We have testers specialized for small force springs and heavy-duty large force springs. Both are able to take measurements for compression and elongation. The surface roughness of a part does more than determine how shiny the object is. Roughness is a direct contributor to surface friction. To measure this characteristic, we employ a profilometer. The profilometer has a precision ground stylus that moves over the surface of a part, measuring the small peaks and valleys that are developed during the machining process. The profilometer then correlates that information and provides the surface roughness of the part in values of micro-inches or micrometers.